Welcome everyone to this new topic on Kubernetes here, in which we are going to talk about what exactly is in Kubernetes and how we can make use of that. So Kubernetes, what exactly is the purpose of using Kubernetes, benefits, architecture, and ultimately at last we will be having a short demo on the Kubernetes here. Now Kubernetes, what exactly is a Kubernetes tool all about here? Now we talk about Kubernetes as we consider it as an orchestration tool, like a container management tool there, where we can manage multiple containers both on physical infrastructures or onto the cloud infrastructure there. Now what happens that we can pretty much deploy the Docker containers with the help of Docker on the Docker engine or Docker host also there, but there are some limitations, like we cannot have an high availability, we cannot have a auto failover, we don't have the auto scaling. A lot of features does not exist in case of the standalone Docker. So in order to keep in mind, in order to go ahead with that, so we require us another tool which is known as Kubernetes. Now Kubernetes is known as the orchestration tool for the fact that this can manage and handle multiple containers. So it's not like only one or two containers which we are talking about, it's like a plenty of number of containers we want to do here. So pretty much one single cluster of Kubernetes can help you to manage like different projects and the different containers as such here. So this is something which is very important because it's a very easy to utilize. It's an open source tool which is available there, and it helps you to deploy the containers, Docker containers, across different environments. The failovers is there, the auto scaling, a lot of additional features like the modern application features which you want, which you require, you can actually utilize over here in case of Kubernetes. So Kubernetes is something which is very important and helpful for us because of the fact that it helps us to define a lot of implementations. What exactly is, let's talk about the analogy over here, right? Now assume that you have a house of 5 rooms, like there is a house which is having like altogether 5 rooms over there. There is a constraint of that how many rooms will be available there. Now you want to rent out like 2 rooms through the air, BNB, like that's the platform which you want to use. So you want to go ahead with that part. You want to proceed further with that 2 extra rooms, like you don't want to use it. Now for this one you got like 2 choices. What are those choices here? First, you either go for a particular ad and you monitor it yourself, like you do it for yourself over there, or you can hire a person to do that particular activity for you. Of course, like if you feel like you can manage the things and you have got enough time for that, you can go for the the direct management for that. But if you don't have the capability and you don't have the time for that and you don't have the enough resources, then of course you have to hire a person which will be taking care of this activity for you over here. Now if you choose any particular agent, now agent responsibility would be like hire the employees which will meet your requirements, like cleaning the rooms, maintaining the rooms, because it's not only about having the tenants, it's also about like keeping or maintaining the rooms also, because that should be cleaned down over the period of time, and a lot of management work or maintenance work required over there. So that's a complete work which will be taken care by the agent, and he's not going to do all the work as such. He maybe hire some more employees for you to do that particular activity. But yes, he is going to manage, he is going to be a single point of contact for keeping of all these things. So he will be taking care of all the records, like how many tenants came in, how much cost is there, but it's the total revenue. So all that things will be done or will be taken care by the agent. So agent is going to take care of all those things as such, so that we don't fail any kind of issues, and it will be readily available for the owner. Like owner can just reach out to the agent and get all these required details. Right. So what is the relationship of Kubernetes over here in this case? So let's talk about that. Let's talk about the relationship, because we talk about this real-time scenario. So how exactly Kubernetes fits in over here? So the facility which you get from the agent, that which can employ other components, or which can help you to do all the work for you, and you don't have to take care of anything. That's where the Kubernetes comes in. So Kubernetes will be deploying like different applications there, and you don't have to do any kind of management work as such there. So Kubernetes is something which is there in place of this agent, which takes care of all the requirements, or small or big requirements as such here, whether it's a maintenance of the node, whether it's a deployment of the application. So end-to-end applications or activity will be performed by the Kubernetes here. So what are the different benefits which we get with the Kubernetes here? So let's talk about the different benefits. Now the different benefits which you get over here is the better infrastructure. So better infrastructure is definitely the something which we are trying to look forward over here. Better management through modularity, so that's another benefit which we get over here. The deployment, rollbacks, the rollouts, the scaling, auto scaling, manual scaling, all these things are quite easy in case of Kubernetes. So Kubernetes provides all these additional benefits where we don't have to rely on the things manually. Pretty much with the help of a good amount of automation, we will be able to get all these issues resolved as such over here. So that's the biggest benefit which we get with the help of these components as such here. And then it will help us to lay down the foundation of the cloud native applications here. So that's also something which we will be using, and where we will be seeing like how the overall implementations can be really achieved over here in this case. So these are some couple of benefits which we really get, so that we can see that how the implementations and the setups can be really achieved over here. So all these things really helps us to see like how the overall implementations, like these are the high level of benefits which we get foresee over here in this one, so that we will be able to understand like, yes, these are the different set of benefits which we pretty much get over here in this case of Kubernetes. So if we summarize, the most important benefit of the Kubernetes is like in a particular sequence, it will help you to deploy your application, right? And it's not like one-on-one application getting deployed. Multiple systems, multiple machines, you can actually deploy your applications, and it can really function properly over there. So you don't have to manage the things. You can pretty much with the help of the Kubernetes manage all these containers. These management of containers can be quite easy with this one. Now let's talk about the architecture of Kubernetes here. So Kubernetes architecture is all about like various components. Now we got a scheduler over here, which is going to manage like most of the scheduling part. We got the controllers, which is the internal components of the Kubernetes, which manages like all the controllers should be up and running, and it's responsible for performing the internal activity. And etcd is in kind of a data store here. Now every application requires some backend to store the information. So etcd is something which acts like a backend for the Kubernetes. And then of course we got the API server, which is available there. The API server is something which we are going to use, which acts like a main component. So all the components of the Kubernetes, whether it's a master or node, is directly integrated with the API server. So the communication between the master and slave or the node machines are actually there with the help of API server only. And then on the node machines, you got like kubelet, because this is a high level environment of the Kubernetes here, where we got like multiple nodes on which the Kubernetes pods or the containers are getting deployed. So you can see like kubelet, kubeproxy pod. These are the different components which is available there on the node machines on the another environment on the another server here. So combine these becomes a complete architecture over here. The master slave architecture is what we are getting over here in this one. Right. So let's talk about these components one by one. First, we'll talk about the architecture components of the master here. So scheduler is something which is responsible for assigning the pods to the nodes here. Now I say like, let's deploy the pod of the specific Jenkins. Now when I do that, so in that case what will happen, that my request will be sending on to different node machines. The different node machines which is available will be taking up that request, and then it's going to say that, okay, let's go ahead, let's execute that and proceed with that particular component. So these are the different components which is available, which is giving us the way like how the executions and the setup needs to be performed. So again, we are using a terminology called pod. So in case of Docker, we call it as Docker container, but in case of the Kubernetes, we call it as an pods over here. So that's what we are trying to use. So pods is what we are trying to deploy, as such as the standalone unit which we deploy in case of Kubernetes cluster. So that's what we call it as in pods here, right? Now the scheduler is something which will assign the task, like on which particular machine we are going to deploy our application, our particular component here. So that's what we are trying to deploy, so that we will be able to see like how the application will be really deployed over here, and on which node it will be deployed. So all that decision factor is something which will be taken care by the Kubernetes here. So that's where the Kubernetes takes up the decision that how to deploy the application. And the assigning of these resources will also be depending on the number of resources, like what kind of resources are available there. So what kind of memory and other details which is being available. So that also is being taken care in regard. So while doing the deployment, all these things will be taken care here. So next thing is the controllers. Now there are different controllers which is available there. So we got like a node controller, we got like a replication controller, we have also got like endpoints controller, and then the service account and the token controllers over here. So these are the different controllers which is available, which we are using, so that we will be able to see like how the executions will be done and how we are going to use these different components as they. So when we talk about these controllers, these are the components which is really responsible for keeping your overall Kubernetes cluster up and running. So if these any of these controllers is not working fine as expected, so that is where the real problems will start coming up over there. So you need to have the specific, you need to have the overall system which needs to be implemented over here. So controllers are very important for your Kubernetes cluster, because without this one, your whole node will be not working as expected. Right, so node controller is something which is responsible for monitoring all the nodes which is available there in the master and this complete cluster here, this multi-node cluster. So we will be using the node controller to manage or to monitor the different node machines here. The replication controller, it helps you to do the replications. For instance, like we have the replication mechanism that if something happens to the pods, if the pods gets corrupted or deleted, then a replicated pod will be immediately created over there. So keeping in mind, we can actually go ahead with that setup. So we can see like, okay, if we are facing the issues like this, if anything goes down, immediately we will be able to have a replica, and this replica will be again back there to make sure that the application is always up and running, and we will be able to get the desired output there. So that's the replication controller which we utilize here. Then we got the endpoints controller, which is used to merge the services and pods. So the request from the services will be then sent out to the specific pods there, and then the connectivity will be established. So for that particular part, for that connectivity is where we will be using the endpoint controller here. And then the service account and token controller. So these are something which is being used so that the API access tokens can be utilized there. So this is something which is being used for the API communications, so that you will be able to see like how the execution needs to be done, like how the setup and modification should be performed here. So when we talk about like all these different controllers, so these are something which can really help us to see like how the overall executions should be done and should be achieved here. So these are the different controllers, and these controllers are making sure like the Kubernetes cluster is always up and running, and any of these controller, if it's not working as expected or there is any kind of issue, so the Kubernetes cluster will not be stable and it will be unstable over here. So these controllers should always be up and running in order to have the stable environment. Now next one is the etcd component. Now etcd component is considered as a data store for your Kubernetes cluster. Like this is something which is being used as a data store here, which means like when you working with the Kubernetes, so it requires some kind of a database. So for that part, what we do is like we basically use the etcd, and this etcd is something which will have the information related to the pods and deployments, everything stored there. So when you are working with the particular Kubernetes cluster, so it does not support any kind of MySQL or that kind of heavy duty databases. So these kind of databases like etcd will be utilized by the Kubernetes here for storing all the information and the desired values here. and it's something which is going to store all the data, like what is the configurations, what is the deployment, what is the services details, what is the pod information. So all that information we will be able to get with the help of this etcd here. And all the port forwarding rules and those activities are also getting stored in these data stores. So it's kind of a complete database which is there for the Kubernetes, and anything which is getting stored is getting stored as such in case of the etcd here. So etcd is very important to consider, like how we are going with the component implementation here. Then we got the API server. Now API server is acting like a backend here. Now when we talk about API server, so it's having a kind of a component called kube-API server here. So it's a main component which does most of the processing there. So all the internal processing will be taken care by the API server, and this API server is directly connected with all the components. So all the requests will be sent to these components there. So once the specific configuration is done, once the setup is done, so you will be able to see like how the processing and the output will be processed here. So this API server is something which definitely helps us to see like how the executions is going on, how the scheduling of the things should be done. So it's a main component, like it's a core component which takes care of most of the component, most of the implementation here. So it's a very important component of a Kubernetes cluster. So now let's talk about the specific API server components here, like how exactly it works on. Now when we talk about the node machines, so here we got like three components: kubelet, kubeproxy, and pod here. Now kubelet is a kind of a process which is there, which is being deployed on the local machine. On each and every node machine you will have the kubelet, and this kubelet will be interacting with the API server. So from there the communication will be happening, like how the execution should be done, and we will be getting the output here.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
And then we have got like kubeproxy. Now when we talk about kubeproxy, it's responsible for the network rules, like all the redirection of the network requests is something which we do with the help of kubeproxy. So kubeproxy is something which will be doing the network redirections of the request, like how when we put up a request on a specific node, how it internally goes on to the specific survey. So all that redirection of the request to the traffic redirection to a specific pod is being taken care by the help of the kubeproxy here. And then pods is there, like which is available, like how we can use the pods on a particular cluster. So each and every node machines may have like specific kind of setup over here, so where we can see that automations, like we can deploy these pods as such on the clusters, and we can see like how the deployments will be done. So pod is the actual container where the application will be deployed, and it's something which can be distributed across different node machines. So depending on the Kubernetes cluster, it will be deployed like across different machines or servers as such. Right. So let's go for a demo to see like how we can run some couple of Kubernetes kubectl commands here, and see like how the executions needs to be done. Try to get some resources which is being deployed on the Kubernetes here. So let's connect to a Kubernetes cluster. So first, let's see like what are the different node machines which is available there. So kubectl get node command is something which will help us to see a node over here. Right now we have got only one node, which is the master node here, but if you feel like you want to get a little bit more additional information about this node, so you can run like kubectl describe node and the node here. So node name is what you can provide over here, and then you can get a series of information, like what are the series of information you will get over here is like what is the name of the node here, what is the role here, it's master, and you can get some particular conditions. You get the IP address, the internal IP address over here, what is the OS image. All these information is what you're trying to get over here in this one, so that we will be able to see like how the execution needs to be done over here in this case. Now when we are trying to perform the automations, like when we are trying to do the setup over here, so this is where like all the configuration is being done. So this is the CPU here, this is the particular memory, and regarding that all the information will be available here. So what is the architecture, all these components will be available and will be performed over here. Now this is the node information. When we run like kubectl get pod, so we get the custom pods which we deployed over here. but we also have certain pods deployed. So for that, I have to go for all namespaces. Like namespaces is a kind of a space which is available in Kubernetes. Now kube-system is an internal namespace. So but when you run the kubectl get pod, so you get the all custom deployed pods which you deploy, but kubectl get pods and the kube system namespace here is actually going to show you like what are the different components which is available there. So all the components which we talked about, like API server, the controller, the proxy, proxy in the sense the services, kube proxy, the scheduler, then the etcd, all those components will be available over here. So you will see those components. And if you talk about the services, so services is also something which is available there. So when you deploy your custom services, you deploy your custom application or the parts here, you will get your own services available here. So in this one, you will be able to see like, okay, these are the couple of services which is available there, where we want to redirect our traffic to a specific parts here. And if you feel like you want to do a describe on a specific part, so you need to say like, okay, the describe kubectl describe pod and a pod name over here. So pod name, you can see like, let's say like you want to go for the API server here, you go for that, and then you need to put the namespace here. So -m is something which is there for the namespace, and I know now that it's running on the kube-system namespace here. And the moment you do this one, you will be able to get all the informations, like all the different details will be available here to you. Like you can get the complete information, like what is the particular components running here, what is the IP address here, what is the containers you are running here, everything will be available here. So this completely gives you the insights like how the execution of the Kubernetes cluster is going on there, and you can pretty much go ahead, you can deploy a couple of containers and a couple of pods you can deploy, and you can get your custom applications deployed. So this is a mechanism like how you can pretty much go ahead and you can manage some couple of services and some couple of deployments as such on the Kubernetes cluster. So let's go back for the main content there, right? So these are the different commands. Now we also got a command called kubectl get pods all namespaces -o-wide, which will give you a kind of wider information like how many IP addresses there, or which node it's running, if multiple nodes are there, so you will get the nodes information. So this is an additional command which is there in place of the kubectl get pods, where you get an add-on informations, like these are the additional informations which we are talking about. So these are the different components or different commands which is available there, which depending on a requirement you can play, and you can see like how the deployments can be done here, right? So this is what we have in the case of Kubernetes, where we talk about like how we can make use of Kubernetes and what are the different benefits we get with the help of Kubernetes here. So that's it for this, guys. Thanks.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.